What if the secrets of the universe weren't discovered in a modern lab, but whispered in stories told thousands of years ago? Picture this: ancient priests in Babylon gazing at the stars, carving myths into clay tablets, unaware that their tales held startling truths about reality itself. These stories weren't just folklore, they were cosmic riddles waiting for science to catch up. Because here's the thing, buried in the symbols and legends of Babylonian mythology are ideas that mirror the strangest, most mind-bending principles of quantum physics. Particles that exist in two places at once. The Babylonians described something eerily similar: the fabric of reality as a web of interconnected energies. They painted it in myth long before physicists proved it. This isn't just coincidence. It's a mystery that forces us to ask, how could a civilization without telescopes or microscopes glimpse truths that took us millennia to uncover? Were they tapping into something deeper, a universal understanding lost to time? Or is there something about the human mind that, when stripped of modern distractions, can sense the fundamental nature of existence? Today, we're diving into one of history's most fascinating overlaps, where ancient mythology and cutting-edge science collide. We'll unravel how Babylonian creation stories, gods, and even their cosmology seem to dance with the same paradoxes that keep quantum physicists awake at night. But this isn't just about decoding the past, it's about what these echoes across time reveal about us. If myths written in cuneiform can align with the math of subatomic particles, what else might we be missing? What other wisdom is hidden in plain sight, waiting for us to see it with fresh eyes? By the end of this journey, you won't just see Babylonian myths as old stories, you'll see them as a mirror reflecting truths we're still struggling to grasp. So let's step into the shadows of ziggurats and particle accelerators alike and uncover the startling connections between the world's oldest stories and the universe's deepest secrets. The Babylonian universe began not with a bang, but with a whisper, a swirling, formless ocean called Tiamat, the goddess of saltwater chaos. Their creation epic, the Enuma Elish, paints a world emerging from this endless, undifferentiated void where nothing was solid, nothing fixed. And here's where it gets eerie. Modern quantum physics describes the birth of our universe in startlingly similar terms. Before particles, before light, there was a seething quantum vacuum, a froth of potential where particles blinked in and out of existence like bubbles in a cosmic soup. The Babylonians called it Apsu and Tiamat, the mingled fresh and salt waters of chaos. Physicists call it quantum foam, a seething, unpredictable substrate beneath reality itself. But the parallels don't stop there. The Enuma Elish tells of the god Marduk slaying Tiamat, slicing her body to form the heavens and earth. It's a violent ordering of chaos, a division of the formless into structure. Now zoom forward 4,000 years. Quantum field theory describes our universe as a tapestry of vibrations, energy condensing into matter, fluctuations freezing into the particles that build stars. Both stories share a core truth: reality isn't static. It's a dynamic interplay between chaos and order, a dance of transformation hidden beneath the surface of what we perceive. Even Babylonian astronomy hints at this deeper understanding. Their star maps didn't just chart fixed points of light, they tracked motion, change, the illusion of permanence unraveled by time. They saw the universe as alive, shifting, which aligns uncannily with quantum mechanics' insistence that particles exist as probabilities until observed. To the Babylonians, the cosmos was a story still being written. To physicists today, it's a quantum equation still resolving. What's most haunting isn't just the similarity of ideas, it's the language they used. The Enuma Elish speaks of the mingled waters with no horizon, no up or down. Quantum physicists describe the early universe as a symmetry without direction, a state where forces we now consider separate, like gravity and electromagnetism, were one and the same. Both perspectives point to a reality far stranger and more fluid than our everyday experience suggests. So were the Babylonians just spinning poetic metaphors? Or did their myths encode an intuitive grasp of cosmic truths we've only just begun to unravel with equations? At the heart of Babylonian cosmology stands Marduk, the storm god who doesn't just conquer chaos, he sculpts it. When he defeats Tiamat, he doesn't erase her, he transforms her body into the architecture of the cosmos. Her ribs become the vault of heaven, her tears the rivers, her roaring becomes the winds. This isn't destruction, it's alchemy, and in quantum physics we find a startling echo, the Higgs field, an invisible energy web that permeates the universe, turning formless quantum fluctuations into particles with mass. Just as Marduk imposes structure on Tiamat's chaos, the Higgs field shapes fleeting energy into the bedrock of matter. Think of it like this: before the Higgs field interacts with particles, they're like light buzzing through space at full speed, weightless, directionless. But when they catch on this cosmic sticky net, they slow down, coalesce, and gain substance. The Babylonian scribes would have understood this instinctively. To them, Marduk didn't just win a battle, he was the force that made raw potential real. Without him, there was only undifferentiated soup. With him, stars could burn, rivers could flow. The Higgs field plays the same role. Without it, electrons would zip through the universe at light speed, never bonding into atoms, never building the world we know. Here's where it gets even more fascinating. In the Enuma Elish, Marduk isn't just a creator, he's a sustainer. He sets the laws of the cosmos, decreeing the paths of planets and the rhythm of seasons. And the Higgs field, it's not a one-time event. It's always on, a constant presence that keeps particles grounded in their material form. Both are invisible hands shaping reality moment by moment. The Babylonians saw divine will in the turning of the heavens. Physicists see a quantum field in the weight of a stone. But perhaps the most profound parallel lies in the idea of sacrifice. Marduk doesn't just defeat Tiamat, he integrates her. Her chaos becomes the fabric of order. Similarly, the Higgs field isn't separate from the particles it shapes, it's deeply entangled with them. When scientists at CERN discovered the Higgs boson, they weren't just finding a particle, they were glimpsing the ripple of a field that gives itself to create mass. The ancient myth and modern science share a haunting truth. Order isn't imposed from outside. It emerges from the very chaos it transforms. So were the Babylonians doing physics without realizing it. Not exactly, but their myths tap into a deep intuition about how reality works, that beneath the surface of things, there's a dance of forces turning the formless into form. Whether you call it Marduk or the Higgs field, the message is the same. The universe isn't just built, it's woven moment by moment from the interplay of chaos and the hand that shapes it. Tiamat's body, torn apart to forge the cosmos, holds a secret far stranger than even the Babylonians could have guessed. When Marduk splits her form, her flesh doesn't just scatter. It remains linked, her ribs arching into the sky while her blood flows as rivers below. Separate yet mysteriously connected. Now consider this: in quantum entanglement, particles born from the same source stay intertwined no matter how far apart they're pulled. Change one and the other instantly responds, as if space and time don't exist between them. Einstein called it spooky action at a distance. The Babylonians might have called it Tiamat's enduring will. This isn't just poetic symmetry. Quantum non-locality, the idea that particles can influence each other across vast distances, challenges everything we thought we knew about reality. It's as if the universe remembers their shared origin, just like the heavens and earth in the Enuma Elish remember they were once part of the same divine body. Scientists still struggle to explain how entangled particles communicate faster than light, but the myth offers a metaphorical clue. Tiamat's body wasn't truly divided. Her essence persisted, a hidden unity beneath the illusion of separation. Take the famous EPR paradox, where two electrons are entangled so that measuring one's spin instantly determines the other's, even if it's light years away. It's as if Marduk's act of splitting Tiamat didn't sever her connection, but revealed a deeper layer of reality where distance is an illusion. The Babylonians didn't have the math to describe this, but their myth captures the feeling of it, a universe where things once joined never truly part. Even the language they used resonates. The Enuma Elish describes Tiamat's body as stretched wide to form the cosmos, suggesting a tension, a pull between her pieces. Quantum entanglement isn't a passive bond, it's an active relationship, a dance of instant correlation. When physicists fire entangled photons toward opposite ends of a lab, their polarization stays synchronized, defying classical logic. Similarly, Tiamat's ribs, the heavens, still echo her roar as thunder, her tears as rain. The myth and the science share a radical idea. What we see as separate is, at some fundamental level, still talking to itself. Here's where it gets even weirder. In quantum mechanics, this entanglement isn't rare, it's the default. Particles are constantly splitting, merging, and sharing states, weaving an invisible web of connection. The Babylonians saw this web as divine will, the threads of fate spun by gods. Modern physics sees it as quantum coherence, the substrate of reality itself. Both point to a universe far more alive than it appears, where every piece remembers where it came from. So why does this matter? Because if ancient myths like the Enuma Elish can intuit truths that took science millennia to formalize, maybe they're more than stories. Maybe they're maps not of the stars, but of the mind's ability to sense patterns deeper than logic. The Babylonians looked at the sky and saw a fractured goddess still whispering to her scattered parts. We look at entangled particles and see math that defies locality. Different languages, same revelation. The universe doesn't play by the rules we thought it did. And sometimes the oldest stories hold the sharpest mirrors up to reality's deepest mysteries. The Tablet of Destinies wasn't just a sacred object in Babylonian mythology, it was the cosmic switchboard of reality itself. This divine tablet, wielded by the gods, didn't just predict fate, it determined it, etching the laws of existence into the universe. But here's the twist, the tablet wasn't fixed. It could be stolen, contested, even rewritten, as if destiny itself was a fluid script. Now, fast forward to quantum mechanics, where particles don't follow strict paths but exist as probability waves, ghostly clouds of could be until the moment they're observed. Both ideas point to a universe where certainty is an illusion, and the bedrock of reality is softer than we think. Take Schrödinger's famous thought experiment, where a cat in a box is both alive and dead until someone looks. The Babylonians would have understood this intuitively. Their Tablet of Destinies didn't just describe the future, it held all possible futures in suspension until a god or a thief intervened. In quantum terms, the tablet wasn't a ledger of fixed outcomes but a wave function, collapsing into a single destiny only when acted upon. The parallels are uncanny. Both systems reject the idea of a clockwork universe, instead revealing a cosmos humming with potential, where nothing is final until it's chosen. Even the language of myth and physics overlaps. The Tablet of Destinies was said to hum with the names of all things, a poetic echo of how quantum fields vibrate with the potential of particles. And just as the tablet could pass between gods, shifting power and fate, quantum states can decohere, their probabilities unraveling when entangled with the environment. Both frameworks suggest that reality isn't a static stage but a dynamic negotiation, where what is depends on who's holding the pen or the particle detector. But the most profound connection lies in the idea of agency. In Babylonian myth, even the supreme god Marduk had to seize the tablet to enforce his will, implying that fate wasn't absolute but participatory. Similarly, in quantum mechanics, the observer plays an active role. The mere act of measurement doesn't just reveal a particle state, it creates it. The Tablet of Destinies and the quantum wave function both whisper the same unsettling truth. Reality isn't something that happens to us. It's something we collaborate with moment by moment. So why does this ancient metaphor resonate so deeply with cutting-edge science? Perhaps because both are grappling with the same fundamental mystery, the unsettling flexibility of existence. Whether carved in cuneiform or coded in equations, the message is clear: the universe isn't a rigid machine. It's a story half-written, waiting for the next hand to pick up the pen. The Babylonians saw duality woven into the fabric of their cosmos, not as a paradox but as a sacred partnership. At the heart of their pantheon stood Shamash and Nergal, twin gods embodying forces that seemed opposites yet were inseparable. Shamash, radiant as the sun, rode his chariot across the sky, scattering light like an endless wave. Nergal, lord of the underworld, ruled the hidden realms where things took solid, unyielding form. Together, they painted a picture ancient scribes could never have known would mirror one of quantum physics' most baffling truths: that light and all matter exists as both wave and particle. Shamash's domain was the ephemeral, the shimmer of heat on sand, the rippling glow of dawn. His light behaved like a wave, spreading, diffracting, bending around obstacles. Nergal's realm was the concrete, the weight of stone, the sharp edge of a blade. His energy was localized, definite, particulate. To the Babylonians, these weren't conflicting ideas but complementary halves of existence. And here's where it chills the spine. Modern quantum experiments reveal light does exactly this. Shine it through two slits and it creates an interference pattern like waves overlapping in a pond. But catch it with a detector and it strikes like a tiny bullet, a particle. Light refuses to be just one thing, just as Shamash and Nergal refused to be parted, their stories forever intertwined. This duality goes deeper than metaphor. In the Babylonian worldview, Shamash didn't just bring light, he brought justice, revealing hidden truths by illuminating all corners. Waves, too, have this revealing quality. Think of ultrasound imaging, where sound waves map the unseen. Nergal, meanwhile, was the god of focused destruction, his wrath precise as a spear thrust, just as particles deliver energy in concentrated packets, like photons knocking electrons loose in a solar cell. The ancients encoded in myth what physicists now quantify. Reality's building blocks are both spread out and pinpoint, depending on how you look. The real magic lies in how the Babylonians reconciled these twins. Their myth shows Shamash descending nightly into Nergal's underworld, not as a prisoner but as a visitor, swapping roles effortlessly. Quantum objects do the same. An electron orbiting an atom isn't a particle or a wave, it's a hybrid that switches masks based on context. Even the language mirrors. Nergal's Akkadian name means the one who tears apart, echoing how particles collide and shatter in accelerators, while Shamash's name derives from Shamu, meaning sun, the ultimate source of undulating light. Perhaps most striking is how these gods govern transitions. Shamash presided over the liminal, dawn and dusk, while Nergal guarded thresholds between life and death. Quantum systems, too, exist in liminal states like superposition, where particles hover between possibilities until measured. The Babylonians didn't see these dualities as contradictions but as layers of a deeper truth. That reality is fluid, its nature shifting with perspective. So next time you hear that light is both wave and particle, think of Shamash and Nergal, the radiant and the shadowed, forever dancing across the boundary between seen and unseen. Their myth survives not as outdated cosmology but as a prescient hymn to the universe's most elegant secret, that nothing is ever just one thing. And if that doesn't make you look at ancient stories and modern science with new wonder, perhaps you're not looking hard enough. Gilgamesh's desperate search for eternal life in the world's oldest epic isn't just a hero's journey, it's a mirror to one of quantum physics' most unsettling truths. The king of Uruk rages against mortality, demanding answers from gods and sages only to learn a bitter lesson. immortality isn't something you find. It's something you create by how you live, how you're remembered, and in that ancient revelation lies a clue to the observer effect, the quantum principle that reality shifts under the weight of our gaze. Both stories whisper the same unsettling idea: existence isn't passive, it responds to the act of being witnessed. Consider the famous double-slit experiment, where particles change behavior based on whether scientists measure them. Leave them unobserved and they behave like waves spreading out in possibilities. But the moment you try to pin them down, they snap into definite particles, as if embarrassed to be caught in ambiguity. Gilgamesh's journey follows the same arc. When he stumbles upon Utnapishtim, the immortal flood survivor, he's handed a test: stay awake for 7 days. Simple, right, but Gilgamesh fails instantly, collapsing into sleep. The moment he's observed by Utnapishtim's wife, who marks each day with a loaf of bread, his chance at immortality crumbles. His own awareness of being watched alters the outcome, just like those quantum particles. The parallels deepen when you examine how perception shapes reality in both stories. Utnapishtim's immortality wasn't earned through strength or cunning. It was granted because the gods saw his worth during the flood. His survival wasn't just physical, it was narrative etched into cosmic memory. Quantum systems work the same way. Before measurement, particles exist in a haze of could-be. Observation doesn't just reveal their state, it selects it, collapsing infinite possibilities into a single timeline. Gilgamesh's tragedy is that he never grasps this. He returns to Uruk empty-handed, yet his story, written in clay, recited for millennia, achieves a kind of immortality through collective witness. His life gains meaning not by his own hands, but by ours, reading his tale centuries later. Even the language of the epic echoes quantum weirdness. When the gods warn Gilgamesh that only the gods live forever, they're not stating a fact, they're setting a boundary, much like the Heisenberg uncertainty principle, which says you can't measure a particle's position and momentum simultaneously. Some truths resist being pinned down. Gilgamesh's obsession with immortality is like a physicist trying to force a particle into a single state. The more he tries, the more elusive the answer becomes. His final wisdom, carved into stone, is a surrender to uncertainty. Life which you look for, you will never find. Not because it isn't there, but because it's everywhere, waiting to be shaped by how it's seen. So what does this ancient story teach us about quantum reality? That existence isn't a fixed stage, but a dialogue. Just as Gilgamesh's legacy lives on because we keep telling his story, particles become real because we keep measuring them. The universe, it seems, has always known what science is only beginning to prove. To be is to be perceived. And whether you're a heartbroken king or a subatomic particle, the act of being witnessed is what writes you into the story of what's real. When Babylonian priests mapped the heavens, they didn't see fixed points of light, they saw a language of possibilities. Each star, each constellation, held layers of meaning, shifting with context like cosmic ink blots. The same celestial sign could herald a king's rise or a harvest's ruin, not because the stars lied, but because their truth was fluid, waiting to be interpreted. This idea that reality isn't locked into a single state mirrors one of quantum physics' most jaw-dropping revelations: superposition, where particles exist in multiple states at once until pinned down by observation. Both systems share a radical vision that the universe thrives on potential, on the unspoken what-ifs humming beneath the surface of what we call real. Take the Babylonian Venus tablets, where the planet's movements were recorded not as a single omen but as a spectrum of meanings. A rising Venus might signal war or peace, drought or abundance, depending on the season, the accompanying stars, even the scribe's intuition. Quantum particles behave similarly. An electron in superposition doesn't merely spin up or down, it spins up and down simultaneously, a blur of probabilities resolved only when a measurement forces it to choose. The Babylonians would have understood this instinctively. To them, the stars weren't telegraphing fixed outcomes. They were whispering a chorus of might best, their messages collapsing into clarity only when human hands traced their patterns on clay. The parallels deepen when you examine how both systems handle uncertainty. Babylonian astrologers didn't see ambiguity as a flaw, it was the heart of their craft. They tracked the double hour, a unit of time where day and night overlapped, a liminal space where meanings blurred. Quantum mechanics revels in the same twilight. Schrödinger's famous cat is both alive and dead, not as a paradox, but as a genuine expression of nature's patience before committing to a single timeline. The Babylonians had their own version of this thought experiment, the myth of the Miss Pi, a ritual where a statue of a god existed in superposition, both inert clay and divine vessel, until the ceremony collapsed its potential into sacred reality. What's most striking isn't just the similarity of ideas, but their shared embrace of observer dependence. Babylonian omens required a priest to read the stars, filtering cosmic chaos through human lenses. Quantum systems, too, demand an observer to crystallize probabilities into facts. In both cases, reality isn't a monologue, it's a conversation shaped by the act of witnessing. When a Babylonian scribe wrote, "If Mars lingers in Cancer, the king will fall," the prophecy wasn't absolute. It needed human eyes to give it weight, just as a quantum wave function needs a detector to become a particle. This isn't mere coincidence, it's a testament to how deeply the human mind intuits the universe's true nature, even when the tools to prove it are millennia away. The Babylonians, with no telescopes or particle colliders, sensed that the cosmos resists binary answers. Their astrology wasn't primitive science, it was a poetic framework for grappling with the same fluidity that quantum equations now describe. Both systems remind us the universe isn't a static painting. It's a palette of hues waiting for the brush of attention to bring one shade into focus, while the others, for that fleeting moment, remain vibrantly, impossibly, all there at once. The Babylonians didn't just chart stars, they listened to their spin. Their zodiac wasn't a static belt of constellations, but a wheel in perpetual motion, each sign cycling through the seasons like celestial clockwork. This obsession with rotation runs deeper than astronomy. The same principle that guided their star priests, that behavior is defined by cyclical patterns, echoes in one of quantum physics' most fundamental traits, spin. Not the spin of a top or a planet, but something far stranger, an intrinsic angular momentum woven into the fabric of particles themselves. Think of quantum spin like this. Every electron, every quark carries an invisible whirligig inside it, a property as essential as its charge or mass. It's not that particles are literally twirling, they're not, but their behavior acts as if they are, dictating how they interact with magnetic fields, how they bond into atoms, even how they resist being crammed together. Now rewind 4,000 years, the Babylonians divided the sky into 12 signs, each governing a slice of the year's turning. Aries didn't just symbolize spring, it was spring's engine, its rotational phase shaping events on Earth. In both systems, rotation isn't just a detail, it's the hidden hand guiding reality's rules. The parallels get spookier when you examine how both frameworks handle direction. Babylonian astrology assigned meaning not just to which sign the sun was in, but to its path rising, zenith, setting. Quantum spin, too, isn't a single value but a directional property called spin up or spin down, determining how particles align in a magnetic field. Both systems treat orientation as destiny. Just as the zodiac's Taurus could signal abundance when ascending but strife when descending, an electron's spin direction decides whether it bonds or repels, builds or destroys. Even the math sings in harmony. The Babylonians used base 60, a number divisible by 12, to map the heavens, a system that still shapes our clocks and circles today. Quantum spin, meanwhile, is quantized in half-integer values, 1/2, 3/2, always multiples of a fundamental turn. This isn't arbitrary. Both systems are grappling with the same truth. The universe ticks in discrete steps, not smooth sweeps. When a Babylonian priest tracked Jupiter's retrograde a staggered backstep against the stars, they were glimpsing the same staggered rhythm physicists now see in the spin of quarks. But here's the real magic. The zodiac wasn't just predictive, it was participatory. Rituals timed to lunar phases or solstices weren't passive observations. They were attempts to sync human actions with cosmic rotation. Quantum spin, too, demands engagement. To measure it, you don't just watch, you intervene, using magnetic fields to tip particles into revealing their spin state. Both frameworks reject the idea of a detached universe. Instead, they paint reality as a dance where observer and observed twirl together, each step changing the other's rhythm. So was the zodiac a secret physics lesson? Not exactly. But in their meticulous tracking of celestial cycles, the Babylonians may have stumbled onto a deeper pattern, one that whispers through time from clay tablets to quantum labs. Whether you're reading the stars or measuring spin, the message is the same. To understand how things move, you must first learn how they turn, and sometimes the oldest wheels hold the truest grooves. To the Babylonians, the future wasn't written in stone. It was hidden in the liver of a sacrificed sheep. Extispicy, their practice of reading animal entrails, may sound barbaric to modern ears, but beneath the blood and ritual lay a startlingly sophisticated idea that chaos holds meaning. Priests would examine the shape, texture, even the blemishes of a liver's lobes, treating each irregularity as a divine cipher. There was no correct reading, only patterns to interpret, chance events to decode. And here's where it collides with quantum mechanics. Both systems treat randomness not as noise, but as the universe's mother tongue. Quantum indeterminacy insists that at the subatomic level, outcomes aren't preordained. An unstable atom decays at a random moment. A photon's path bends unpredictably. This isn't ignorance of hidden variables, it's baked into reality's core. The Babylonians would have nodded in recognition. To them, a liver's mottled veins weren't flawed. They were a celestial fingerprint, unique as a quantum fluctuation. Both frameworks reject the illusion of absolute determinism, embracing uncertainty as the soil from which meaning grows. Consider Schrödinger's radioactive atom, poised between decay and stability until observed. The Babylonians had their own version, a sheep's liver fresh from sacrifice, suspended between states ordinary organ or oracle until the priest's gaze collapsed its potential into a message. The parallels are uncanny. In quantum mechanics, observation forces a probabilistic system to choose a state. In extispicy, the act of interpretation transformed random entrails into prophecy. Both reveal a universe that speaks only when questioned, its answers shaped by the very act of asking. Even the tools align. Babylonian diviners used clay liver models, training aids marked with zones corresponding to gods and omens. These weren't rigid maps but flexible guides, much like the probability clouds physicists used to describe where an electron might be. Neither system claims to predict with certainty. Both chart likelihoods, acknowledging that the universe retains the right to surprise. When a priest traced his finger across a liver's fissures, he wasn't deciphering fate. He was navigating a terrain of possibilities, just as quantum physicists calculate wave functions without ever claiming to know a particle's next move. The deepest connection lies in what these practices reveal about human intuition. Faced with a random universe, both Babylonians and quantum physicists did the same thing. They built frameworks to converse with chaos. One used ritual and myth, the other matrices and detectors, but both understood that randomness isn't the enemy of meaning. It's the raw material. When modern scientists peer into a cloud chamber, watching particles zigzag like drunken fireflies, they're not so different from those ancient priests, squinting at a liver's grooves, trusting that even in the erratic, there's a pattern waiting to be heard. Perhaps that's the real lesson echoing across millennia. Whether you're splitting atoms or reading entrails, the universe refuses to be pinned down. It flickers at the edges, whispering through chance and choice alike. The Babylonians called it the will of the gods. We call it quantum probability, but the heart of it remains the same. Reality doesn't roll dice. It writes poetry, in blood, in light, in the spaces between what we see and what we sense. And sometimes the oldest ways of listening still catch the clearest echoes. Enki didn't just rule the sweet waters of the Abzu, he presided over the fluid architecture of knowledge itself. In Babylonian myth, this god wasn't a brute force like Marduk. He was a weaver of systems, a deity who organized the cosmos not through conquest but through encoding. His temples doubled as libraries, his symbols as ciphers, and in that role he becomes something startlingly modern, a personification of quantum information theory, where data isn't locked into rigid binaries but floats in a sea of possibilities waiting to be read. Think of Enki's most famous act distributing the me, the divine decrees that governed everything from music to shipbuilding. These weren't commandments carved in stone, they were dynamic principles adaptable to context, like quantum bits qubits that hold multiple states simultaneously. A classical computer bit is a light switch, on or off, 1 or 0, but a qubit, it's both at once and everything in between, a superposition of potentials. Enki's me functioned the same way. A single decree about kingship could manifest as justice in one city and tyranny in another, its meaning collapsing into clarity only when applied. The Babylonians understood something quantum programmers now exploit. Information is most powerful when it remains unresolved. This isn't just poetic coincidence. Enki was often depicted with streams of water flowing from his shoulders, each rivulet branching into smaller channels. A perfect metaphor for quantum parallelism, where a single qubit superposition allows it to perform multiple calculations at once. His waters didn't follow straight paths, they entangled, intertwining in ways that mirrored quantum gates linking qubits into circuits. Even the god's mischievous streak aligns with quantum unpredictability. In one myth, Enki sabotages the cosmic order by getting drunk and misassigning the me, scrambling destinies like a quantum algorithm, introducing deliberate noise for faster computation. Chaos in both systems isn't a bug, it's a feature. The most striking parallel lies in how both frameworks handle retrieval. Enki didn't just hoard wisdom, he stored it in layers, accessible only through ritual and interpretation, much like quantum data, which can't be copied or observed directly without disrupting its state. To read a qubit's information, you must collapse its superposition, destroying other potential outcomes. Similarly, accessing Enki's knowledge required sacrifices, incantations, a transactional exchange where some truths were inevitably lost in the decoding. Both systems recognize a hard truth: perfect knowledge is impossible because the act of seeking it changes what's there. Yet there's a brilliance to this limitation. Just as quantum error correction encodes information redundantly across entangled qubits to protect against decay, Enki's myths were copied onto countless tablets, scattered across cities so no single disaster could erase them. The god's wisdom wasn't stored in one place or form. It was distributed, resilient because it was everywhere and nowhere at once. Modern quantum networks aim for the same robustness, using entanglement to transmit data immune to eavesdropping, a celestial encryption Enki would have admired. So was Enki a quantum physicist in disguise? Hardly. But his myths resonate because they capture an intuition about information that science is only now formalizing. That knowledge isn't static. It's a living thing, shaped by how it's held, shared, and observed. Whether etched in cuneiform or vibrating in a quantum processor, the message is the same: the universe doesn't store its secrets in ledgers. It writes them in shifting waters, and only those who learn to swim in uncertainty will ever drink deep. Beneath the world of temples and ziggurats, the Babylonians believed in the Abzu, an endless underground ocean of fresh water, the source of all life. But this wasn't just a physical sea. It was a cosmic reservoir, a hidden dimension where creation bubbled up into existence. Now, fast forward to the quantum vacuum, the so-called empty space that modern physics reveals isn't empty at all. It's a seething ocean of energy, particles flickering in and out of existence like bubbles in the Abzu's depths. Both visions share a breathtaking idea. What looks like nothing is actually the womb of everything. The Abzu wasn't a passive pool, it was alive with potential. Enki, the god who ruled it, didn't just guard water, he controlled the patterns of creation, the codes that shaped reality. Similarly, the quantum vacuum isn't static. It crackles with zero-point energy, a baseline hum of activity that never quiets, even at absolute zero temperature. Scientists once called it empty space, but now we know better. It's more like the Abzu's hidden currents, invisible yet powering the universe. When quantum fluctuations birth virtual particles, pairs of matter and antimatter that annihilate in an instant, they're replaying an ancient motif, the Abzu's waters rising and receding, giving form to the formless. Here's where the parallel becomes uncanny. The Babylonians believed the Abzu's energy could be tapped not by force but by understanding its rhythms. Priests performed rituals to draw up its wisdom, mirroring how modern physicists theorize extracting zero-point energy from the vacuum. Both ideas flirt with the same tantalizing possibility, that the fabric of reality is a canvas of untapped power if only we could learn its language. Even the metaphors align. The Abzu was often depicted as a labyrinth, its twisting channels echoing the fractal complexity of quantum foam, that sponge-like structure of spacetime at the smallest scales where energy condenses and dissolves in an endless dance. But there's a darker resonance. Babylonian myths warn that the Abzu's gifts come with peril. Disturb its depths recklessly and you risk unleashing chaos, a theme that haunts quantum physics today. The vacuum isn't just energy, it's instability. Under the right conditions, a quantum fluctuation could, in theory, spawn a catastrophic bubble of new physics, rewriting the laws of our universe in an instant. The ancients personified this danger as the monster Kur, a serpent lurking in the Abzu's depths. We might call it vacuum decay. Different names, same fear, that the foundation of reality is both source and threat. What's most profound isn't just the similarity of concepts, but the shared humility they inspire. The Babylonians didn't claim to master the Abzu. They revered it, acknowledging its mysteries dwarfed human understanding. Modern physics, for all its equations, hits the same wall. Zero-point energy is calculable but uncontrollable. The vacuum teems with power we can't yet harness. Both worldviews confront us with a truth as humbling as it is thrilling. The universe's deepest wellsprings don't yield to conquest. They reveal themselves drop by drop to those who listen. And sometimes the oldest myths map the newest frontiers, not with equations, but with symbols that stir something primal in us. The Abzu wasn't just water. It was a mirror reflecting humanity's oldest question: what secrets lie hidden in the dark beneath our feet? The Babylonians didn't just measure time, they fractured it into 60-fold echoes that still tick inside our clocks today. Their base 60 system, dividing hours into minutes and minutes into seconds, wasn't arbitrary. It was a rebellion against the illusion of smooth, flowing time, carving reality into discrete, countable units. Now, quantum physics whispers the same heresy. What if time isn't a river but a flipbook? What if the universe ticks like a cosmic metronome, moving in indivisible jumps too small for our senses to catch? Think of it like this: when you watch a second hand sweep across a clock face, it seems continuous, but zoom in close enough and you'll find it's actually jumping, each tick a quantum leap, each talk a miniature revolution. The Babylonians intuited this granularity millennia ago. Their sexagesimal system, with its elegant divisibility by 12, 30, and 60, mirrored the cycles they observed: lunar phases, planetary orbits, all natural phenomena that move in steps, not slides. Modern quantum gravity theories, like loop quantum cosmology, propose something eerily similar, that space-time itself might be pixelated, with time advancing in Planck-sized increments of about 10 to the minus 43 seconds. At this scale, the smooth arrow of time shatters into a staccato rhythm, a cosmic drumbeat the Babylonians might have recognized in the pulse of their water clocks. Even their tools hint at this quantum mindset. The clepsydra or water clock didn't measure time by uninterrupted flow. It relied on discrete drips, each drop a tiny quantum of duration. Similarly, quantum theories suggest time might emerge from more fundamental events, like the oscillations of atoms in an atomic clock. Both systems reject the idea of time as an independent backdrop, instead treating it as a web of relationships, a tapestry woven from countable interactions. The Babylonians tracked these relationships obsessively, compiling centuries of eclipse records not as smooth curves, but as tables of discrete occurrences, each entry a snapshot of time's granular fabric. Here's where the parallel deepens. Babylonian astrology treated time as layered linear progression tangled with cyclical returns. A solar year marched forward, yet the zodiac wheel brought seasons back around. Quantum mechanics grapples with the same duality. At the quantum level, particles don't experience time as a one-way street. Entangled particles influence each other instantaneously, as if separated by space but not time, while quantum loops in theories like Carlo Rovelli's relational quantum mechanics suggest time itself might be a network of before and after links rather than a universal flow. The Babylonians would have understood this intuitively. Their great year concept, where celestial patterns slowly repeated over millennia, mirrors the idea of quantum recurrences, where systems eventually return to initial states. But the most radical overlap lies in their shared rejection of time's objectivity. To the Babylonians, an hour wasn't fixed, it stretched or shrank with the seasons, their temporal hours varying by daylight. Quantum mechanics reveals a similar fluidity. Time dilates near massive objects, speeds up or slows down for observers in motion. Both systems insist time isn't a master clock, but a local phenomenon shaped by context. Even the Babylonian practice of intercalation, inserting extra months to align lunar and solar cycles, finds a quantum echo in imaginary time, a mathematical trick physicists use to smooth calculations, bending temporal dimensions like scribes adjusting calendars. So why does this ancient timekeeping resonate so deeply with modern physics? Perhaps because both were born from watching the universe closely, one with naked eyes tracing star paths, the other with particle colliders probing femtosecond decays. The Babylonians didn't have the math to formalize Planck time, but their base 60 system, their layered calendars, even their omens linking celestial events to earthly moments, all whisper and intuition we're still decoding. That time isn't what it seems. It's not a line, not a circle, but something far stranger, a dance of discrete steps, a rhythm older than ziggurats ticking beneath the surface of reality itself. Ishtar's descent into the underworld wasn't just a myth, it was a blueprint for one of quantum physics' most impossible feats. The goddess of love and war didn't march down some ordinary staircase. She faced 7 gates, each stripping away a piece of her divine power until she stood naked before the Queen of the Dead. At first glance, it's a story about sacrifice, but look closer and you'll see something astonishing. Ishtar's journey mirrors how particles cheat reality through quantum tunneling, slipping through barriers that should be impenetrable. Both tales share a spine-tingling truth that the universe has backdoors, hidden paths where the impossible becomes possible. Picture this: in quantum tunneling, a particle like an electron encounters a wall. Classically, it shouldn't have the energy to cross, but instead of bouncing back, it does the unthinkable. It vanishes on one side and reappears on the other, as if the barrier wasn't there. Physicists call it tunneling not because particles dig, but because they bypass the obstacle entirely, like Ishtar passing through those 7 gates without breaking them down. Each gate demanded a piece of her crown, her jewels, her robes, just as a tunneling particle loses certainty in its position or momentum during the leap. By the time she reached the underworld's heart, she was transformed, reduced to her essence. A tunneling particle emerges changed too, its wave function altered by the journey. The parallels run deeper than metaphor. Ishtar's gates weren't physical barriers but thresholds of meaning, each stripping away layers of identity. Similarly, the barriers in quantum tunneling aren't brick walls but energy landscapes, hills of probability that particles surmount not by force but by fading into ambiguity. The Babylonians would have understood this instinctively. To them, the underworld wasn't just a place, it was a state of attenuated existence, a realm where normal rules dissolved. Quantum systems operate the same way. When a particle tunnels, it doesn't squeeze through. It briefly exists in a ghostly superposition, neither here nor there, much like Ishtar between gates, neither fully divine nor fully mortal. Even the numbers whisper secrets. 7 gates guarded the underworld, a number sacred across Mesopotamian cosmology. In quantum mechanics, tunneling probability drops exponentially with barrier width, but never quite reaches zero. There's always a sliver of a chance, a 7th gate that might yield. Both systems acknowledge a universe where absolutes crumble at the edges. Ishtar's eventual return, resurrected by the gods, mirrors how quantum particles can tunnel back, completing cycles that defy classical logic. The myth and the math share an eerie refrain. Boundaries are illusions, and the cosmos keeps ways in and out we're only beginning to trace. What's most haunting isn't that the Babylonians predicted tunneling, it's that they ritualized it. Priests reenacted Ishtar's descent during festivals, embodying her passage through veils of reality. Today, scientists harness tunneling in microscopes and microchips, manipulating particles to cross forbidden zones. Both practices recognize a truth beyond intuition, that the universe is porous, layered with gateways only the bold or the quantum can navigate. Whether you're a goddess shedding her jewels or an electron ignoring Newton's laws, the lesson is the same. The impossible is just a doorway waiting for the right key, and sometimes the oldest stories hold the first maps to the cracks in reality's facade. The Anunnaki weren't just gods, they were cosmic architects, each shaping a slice of reality according to their own divine will. In Babylonian mythology, these deities didn't merely rule. They partitioned the universe, dividing creation into domains of sky, earth, and underworld. But what if these divisions weren't just symbolic? What if the Anunnaki's realms were early whispers of a truth quantum physics now grapples with, that our universe might be one of countless others, each branching endlessly like the limbs of a celestial tree? Take Enlil, lord of the storm, whose tempests carved the heavens into order. In one version of reality, his winds might have blown gently, nurturing civilizations. In another, they could have razed cities to dust. This isn't just poetic license, it's a striking parallel to the many worlds interpretation of quantum mechanics, where every decision, every chance event, splits existence into alternate timelines. The Anunnaki's conflicting myths, where gods wage wars over competing visions for creation, start to sound less like folklore and more like a multiverse in turmoil, each deity presiding over their own quantum branch. Consider how the Babylonians depicted the Anunnaki's council, a pantheon debating fate around a cosmic table, their votes determining the course of reality. Modern physics paints an eerily similar picture. At the quantum level, every possibility plays out simultaneously until observation collapses the system into one outcome. The Anunnaki's debates might symbolize these uncollapsed states, with each god's voice representing a parallel universe where their will prevails. Enki, the trickster, ensures some worlds bend toward cunning. Ishtar's passion ignites others. The myths even hint at entanglement, gods conspiring across realms, their actions in one dimension rippling into others, much like quantum particles influencing distant twins. The most haunting echo lies in the Anunnaki's fluid identities. Ninurta might be a warrior in one city, a farmer in another, his role shifting with each retelling. Quantum decoherence explains this same multiplicity. As universes branch, versions of you make different choices, becoming strangers to one another. The Babylonians encoded this intuition in their gods' mercurial natures, each incarnation a snapshot of a divergent timeline. Perhaps that's why these stories endure. They don't just describe a universe, but a metaverse where every possibility pulses with life. The Anunnaki weren't bound by single destinies, and neither are we. Whether through divine whim or quantum fluctuation, the message is the same. Reality is a tapestry of might best, and every thread is still being woven. The incantation bowls of Babylon weren't just clay vessels, they were cosmic focusing lenses. Buried beneath doorways or hidden in walls, these bowls bore spiral inscriptions, winding spells meant to trap demons and fix fleeting events into certainty. To the Babylonians, chaos wasn't just disorder, it was a swarm of unrealized possibilities, and their rituals sought to collapse those possibilities into a single, stable reality. Strip away the mythology, and you're left with a process startlingly similar to quantum decoherence the moment a quantum system's infinite potential narrows into one observable outcome. Both systems share a radical premise that reality isn't fixed until something acts upon it. Take the famous Sherpu incantations, where priests recited precise phrases to purify a patient by burning away malevolent forces. The ritual wasn't just symbolic, it demanded absolute focus, with every syllable and gesture designed to isolate and eliminate ambiguity. Quantum decoherence operates on eerily parallel principles. When a particle exists in superposition, say, spinning both clockwise and counterclockwise, it's only through interaction with its environment, a stray photon, a measuring device, that it chooses a definite state. The Babylonian exorcist chanting over a bowl of water was playing the role of that photon, his observation, his attention, forcing chaos to resolve into order. Even the mechanics align. Decoherence doesn't happen instantly. It spreads like a wave, with quantum probabilities leaking into the environment until only one outcome remains dominant. Babylonian magic mirrored this gradualism. A single incantation might be repeated for days, its power accumulating like the incremental collapse of a wave function. The Maklu text used to counter witchcraft explicitly describe curses as entangled with their victims, requiring systematic unraveling, a process not unlike how quantum systems lose coherence particle by particle until the original superposition dissolves. Here's where it gets profound. Babylonian rituals often involved mirrors or polished metal surfaces, tools believed to reflect and trap malignant energies. Modern quantum experiments use detectors in analogous ways, measuring devices catch particles mid-flight, freezing their properties into concrete data. Both systems treat observation as an active force, not passive witnessing. A priest gazing into a ritual mirror wasn't just looking, he was participating, his focus shaping the outcome as surely as a physicist's detector shapes an electron's path. But the deepest parallel lies in what both frameworks reveal about agency. The Babylonians believed true power resided in naming things correctly, uttering the exact words to bind a demon or heal a wound. Quantum physics, too, hinges on precise measurement. The act of defining a particle's position or momentum literally brings it into being. Both traditions stumble onto the same unsettling truth: reality isn't a monologue. It's a call and response, a negotiation between the observer and the observed. When a Babylonian scribe wrote, "By the command of Marduk, let this evil be undone," he wasn't just praying. He was initiating a cosmic measurement, collapsing the wave function of misfortune into a single, healed timeline. So were these ancient sorcerers proto-physicists. Not exactly, but their intuition that the universe listens, That attention alters the fabric of things resonates with a science still struggling to explain why observation holds such power. Maybe the incantation bowls held no literal demons, but in their spiraling script they encoded a wisdom we're still deciphering, that to speak a thing's true name isn't just magic. It's measurement, and in that act, possibility becomes fact. The Etemenanke ziggurat didn't just scrape the sky, it aimed to stitch heaven and earth together. Towering over Babylon, this terraced pyramid was more than a temple. It was an ancient theory of everything, a physical manifesto declaring that the cosmos could be unified. Each of its 7 levels, painted in the colors of the planets, acted like rungs on a ladder between mortal and divine realms. Now, fast forward to quantum gravity, where physicists chase their own cosmic ladder, the quest to reconcile the infinitely large gravity with the infinitely small quantum mechanics. Both endeavors share a breathtaking ambition to bridge scales that seem irreconcilable, to find the hidden seams in reality's fabric. Consider the ziggurat structure. Its step design wasn't arbitrary. It mirrored the Babylonian vision of a layered universe where each tier represented a higher plane of existence. Quantum gravity theories propose something eerily similar, that spacetime isn't smooth and continuous but granular, composed of minuscule atoms of reality. Loop quantum gravity, for instance, suggests spacetime is woven from tiny, indivisible loops, like the bricks of Etemenanke stacked precisely to build a monumental whole. The ziggurat's architects didn't have Planck-length calculations, but they intuited a profound truth. The universe is built in steps, not slopes. The parallels deepen when you examine purpose. Etemenanke wasn't just a shrine, it was a conduit. Priests climbed its stairways to perform rituals aligning earthly events with celestial patterns, binding human fates to the stars. Quantum gravity seeks its own kind of alignment, attempting to unify Einstein's spacetime curvature with the probabilistic frenzy of quantum fields. Both frameworks treat the universe as a living equation where the macro and micro must communicate. The ziggurat staircases, like the equations of string theory or causal dynamical triangulations, are attempts to map the hidden pathways between scales. Even the myths surrounding Etemenanke whisper quantum insights. The Tower of Babel story, though biblical, echoes Babylonian anxieties about the fragility of cosmic order. When the tower falls, languages scatter and unity shatters, a poetic metaphor for how quantum gravity's equations often break when pushed to extreme energies. The Babylonians feared the gods would retaliate against human hubris. Physicists fear the UV divergence, where calculations explode to infinity at tiny scales. Both narratives warn, stitching reality together isn't just about ambition. It's about finding the right language. Here's where the connection becomes electrifying. The ziggurat summit housed the Shu Anna, the lofty room where heaven and earth met. Quantum gravity theories posit their own meeting points, singularities inside black holes, or the Big Bang's fiery dawn where spacetime itself frays into quantum uncertainty. The Babylonians marked these thresholds with gold and lapis lazuli. Physicists mark them with event horizons and renormalization groups, but the core idea transcends time. Reality has junctions, places where the rules bend, and the brave, whether priests or physicists, can glimpse the scaffolding behind the illusion. What's most haunting isn't the similarity of ideas, but the shared humility they inspire. Etemenanke's ruins now lie buried in Iraq's soil, a testament to how even the grandest theories crumble. Quantum gravity's equations, for all their elegance, remain unfinished. Both endeavors remind us, unification isn't about conquering the cosmos but listening to it. The ziggurat stairways and spacetime's quantum foam whisper the same lesson. The universe reveals its secrets not in a single epiphany, but layer by layer, step by step. And sometimes the oldest towers cast the longest shadows. Pazuzu, the Babylonian king of wind demons, wasn't a figure of pure evil. He was chaos incarnate, a whirlwind of unpredictable force. With his grotesque hybrid body and winged fury, he embodied the untamable energies that lurked at the edges of ordered existence. To the Babylonians, demons like Pazuzu weren't just supernatural pests. They were manifestations of reality's inherent instability, flickering in and out of the cosmic fabric like shadows cast by a guttering flame. Sound familiar? It should. Swap the horned mask and talons for mathematical notation, and you've got virtual particles, quantum mechanics' own fleet of transient demons, boiling up from the void only to vanish nanoseconds later. Both are born from the same unsettling truth: the universe is never truly still, never perfectly calm. Beneath the surface, it's a seething cauldron of possibility. Take the demon Lamashtu, a monstrous hag who lurked in dark corners, snatching newborns and leaving illness in her wake. She wasn't always present, but her threat loomed in every shadow, her appearances as sudden as they were devastating. Virtual particles operate on the same principle. Empty space isn't empty, it's a frenetic dance of particle-antiparticle pairs that blink into existence, borrow energy from the vacuum, and annihilate before reality can protest. These quantum demons don't last long enough to be measured directly, but their effects ripple outward. Just as Lamashtu's presence was inferred from miscarriages and fevers, virtual particles reveal themselves through measurable forces like the Casimir effect, where two metal plates placed microscopically close together feel an invisible push from the particle's fleeting activity outside them. The Babylonians warded off Lamashtu with amulets. Physicists trap virtual particles with precision instruments. Different tools, same battle against the unseen. Even the methods of containment align. Pazuzu's image was often carved onto amulets worn by pregnant women, a way to bind his chaotic energy into a protective form. Quantum field theory does something eerily similar. When particles interact, they exchange virtual particles like microscopic messengers, effectively binding forces into predictable patterns. The demon's unpredictable rage becomes a force you can harness, just as the chaos of virtual particles gives rise to the stable glue holding atoms together. The Babylonians called this principle Ikabu, the idea that even malignant forces could be redirected with the right incantations or symbols. Modern physics calls it renormalization, the mathematical trick that lets scientists subtract infinite energies from virtual particle calculations to reveal the finite, usable forces beneath. Both systems acknowledge the same paradox: chaos isn't the enemy of order, it's the raw material. Perhaps the most startling parallel lies in how both frameworks handle time. Babylonian demons didn't obey linear narratives. They could appear anywhere, anytime, their actions looping back on themselves like Ouroboros serpents. Virtual particles are equally untethered. In quantum field theory, particles can move backward in time. Antimatter is often interpreted as ordinary matter reversing its temporal path. The demoness Lilitu, a storm-winged seductress, was said to haunt the same moment repeatedly, her curses echoing across generations. Feynman diagrams, those squiggly line maps of particle interactions, depict virtual particles doing the same, popping up in time loops where a particle becomes its own ancestor. The Babylonians saw this temporal fluidity as supernatural. We see it as quantum weirdness, but the underlying message is identical. Time isn't the straight arrow we perceive. It's a labyrinth, and the demons know all the shortcuts. So why does this matter? Because the Babylonians didn't just fear their demons, they dialogued with them. Incantations often addressed Pazuzu respectfully, acknowledging his power while coaxing it toward protection. Modern physics, too, has learned to negotiate with quantum fluctuations, harnessing their chaos to explain everything from black hole radiation to the Higgs mechanism. Both traditions reveal a universe that's alive with roiling potential, where stability isn't the default, it's the hard-won truce between infinite flickering shadows. Whether you're a priest crafting an amulet or a physicist solving wave equations, the challenge is the same: to find meaning in the tempest and maybe, just maybe, bend its fury to your will. King Nebuchadnezzar's restless nights held more than just royal anxiety. They crackled with the same eerie electricity that hums through modern theories of quantum consciousness. When the Babylonian king dreamed of a towering statue shattered by a divine stone, or of a tree cut down to its roots, his scribes didn't dismiss these visions as mere phantoms. They treated them as prophecies, as if the act of dreaming itself could reach beyond time and sculpt reality. Fast forward to today, and cutting-edge science is whispering a similar possibility, that the human mind might not just perceive reality, but participate in its creation, thanks to quantum processes flickering inside our very neurons. The parallels begin with the nature of Nebuchadnezzar's dreams. They weren't passive hallucinations but interactive revelations so vivid, so charged with meaning that they demanded interpretation. Daniel, the biblical prophet summoned to decode them, didn't just explain. He collapsed their ambiguity into specific outcomes, much like an observer in quantum mechanics forces a particle's superposition into a definite state. The dreams existed in a limbo of potential until Daniel's insight crystallized their meaning, an ancient echo of the quantum mind hypothesis, where consciousness itself might be the measurement device that pins reality into place. Dive deeper into quantum consciousness theories, and the connections grow even stranger. Scientists like Roger Penrose and Stuart Hameroff propose that microtubules, tiny protein structures in brain cells, could harness quantum vibrations to generate conscious experience. If true, this means our thoughts might not just be chemical sparks but quantum symphonies, with superposition and entanglement playing out inside our skulls. Nebuchadnezzar's dreams, then, take on a new light. What if his visions weren't supernatural intrusions but amplifications of a mind tuned to quantum frequencies? The statue in his dream, its parts fracturing into disparate materials, mirrors the quantum decoherence that scrambles superposition into classical reality, except here, the observer isn't a lab instrument. It's a king's subconscious wrestling with the weight of empire. Even the symbolism aligns. The tree dream, a cosmic axis cut down but left with a living stump, resonates with quantum biology's most radical idea. That consciousness might persist in some form beyond classical death, like quantum information surviving a black hole's event horizon. The Babylonians saw dreams as portals to divine realms. Quantum consciousness suggests they could be glimpses into the mind's quantum substrate, where time and causality loosen their grip. When Nebuchadnezzar awoke trembling, was he sensing the fragility of reality itself? How easily the world we know could be rewritten by a deeper layer of quantum potential. But here's the twist: the king's dreams didn't just predict the future, they altered it. His actions after each vision, whether arrogance or repentance, shaped the prophecy's fulfillment. This loops back to quantum theory's most mind-bending implication. That observation isn't neutral, it's creative. In the double-slit experiment, electrons decide whether to behave as particles or waves based on how they're measured. Nebuchadnezzar's dreams, once interpreted, set him on paths that made their warnings real. The mind, whether ancient king or modern scientist, isn't just a mirror reflecting reality. It's a chisel carving possibility into fact. So were the Babylonians' proto-neuroscientists, hardly, but their instinct that dreams and waking life intertwine in ways that defy simple causality finds eerie kinship with quantum consciousness theories. Both frameworks dissolve the line between observer and observed, between thought and thing. Nebuchadnezzar's nightmares remind us that the oldest questions, who dreams the world into being, might still hold sway, not in mystic scrolls but in the quantum vibrations humming behind our eyes. And if that's true, then every dream, every thought might be more than ephemera. It might be the universe whispering to itself through the medium of us. The Great Flood in Babylonian myths wasn't just a disaster. It was a cosmic reset button, a cataclysm so profound it didn't just destroy the world, it rewrote it. The Epic of Atrahasis and Gilgamesh describes waters rising not as a random act of divine wrath, but as a necessary purge, a transformation so violent it birthed a new era. Strip away the allegory and you're left with something startlingly familiar. A phase transition, the same fundamental shift that turns ice to water or transforms a superconductor into a flawless conductor of electricity. But what if the flood wasn't just a myth? What if it encoded an ancient intuition about how reality itself can snap from one state to another in an instant, rewriting the rules of existence? Picture the moment just before the flood gods overwhelmed by human noise, the earth groaning under unrestrained chaos. This mirrors the critical point in quantum phase transitions, where a system teeters on the edge of instability. Take liquid helium cooled to near absolute zero. At a specific threshold, it doesn't just get cold, it shatters expectations, flowing without friction as a superfluid. The shift is sudden, total, irreversible. The Babylonians described the flood the same way, not as gradual erosion, but as a tipping point where the old order collapsed into something unrecognizable. Both narratives share a chilling truth. Change isn't always smooth. Sometimes the universe flips a switch. Now, zoom out to the cosmic scale. Modern cosmology's inflation theory proposes that our universe underwent a similar phase transition a fraction of a second after the Big Bang. Space itself expanded faster than light, rewriting the fabric of reality in a blink. The parallels with the flood are eerie. In both an initial stable state, the god's quiet world / the quantum vacuum becomes unstable, triggering explosive transformation. The floodwaters don't just erase, they reconfigure. Just as cosmic inflation didn't just expand space, it seeded the structures of galaxies. The Babylonians saw the flood as divine retribution, but beneath the myth lies a deeper pattern. Systems under tension don't bend. They break, and from that breakage, new worlds emerge. Even the aftermath aligns. Post-flood, Atrahasis' ark comes to rest on Mount Nimush, and a new covenant is struck, a fresh set of rules for humanity. Quantum phase transitions, too, leave relics. When a magnet loses its magnetism at the Curie point, traces of the old order linger in domains like echoes of the past. Cosmic inflation left its fingerprints in the cosmic microwave background, whispers of that primordial shift. The Babylonians ritualized this memory, offering sacrifices to honor the flood's legacy. Physicists, in their own way, do the same, probing cosmic background radiation like priests reading entrails, searching for signs of the universe's first reboot. But here's the real revelation. The flood myths and quantum transitions both hinge on scales of perception. To a human, the flood was an apocalypse. To the gods, it was system maintenance. Similarly, a phase transition looks like chaos if you're an electron caught in the storm. But to a physicist, it's elegant thermodynamics. The Babylonians grasped this duality intuitively. Their flood wasn't just about drowning sinners, it was about rebalancing cosmic energies, a necessary recalibration. Inflation theory says the same. The universe didn't erupt from nothingness. It organized itself, trading instability for structure. So why does this matter? Because these parallels suggest something profound, that the human mind, stripped of equations, can sense the universe's deepest rhythms. The flood myths aren't failed science. They're metaphors so precise they border on prophecy. When a Babylonian scribe wrote of waters swallowing the earth, he wasn't just describing disaster. He was capturing a truth that would take millennia to formalize. That reality isn't static. It's a tapestry of sudden leaps, of hidden thresholds where everything changes in an instant. And sometimes the oldest stories map the most startling frontiers, not with math but with the raw power of a well-told tale. Cuneiform script wasn't just the world's first writing system, it was humanity's earliest experiment in encryption. Every wedge-shaped imprint pressed into wet clay wasn't merely a letter. It was a cipher, a deliberate arrangement of angles and depths that held meaning only for those trained to decode its secrets. A single symbol could shift from grain to heaven based on the scribe's intent, its message secured not by complexity alone but by context, much like quantum encryption's reliance on entanglement and observation to lock information away from prying eyes. Both systems share a revolutionary idea that true security doesn't come from hiding messages, but from weaving them into patterns so intricate they're meaningless without the right key. Take the Babylonian practice of cylinder seals. These carved stone rolls, when pressed into clay, left behind intricate designs that served as signatures, unique identifiers that couldn't be forged without access to the original. Now compare that to quantum key distribution, where particles of light encode cryptographic keys so delicate that any attempt to intercept them alters their state, alerting the sender to eavesdropping. Both methods exploit the same principle. Security lies in the unrepeatable. The seal's microscopic grooves were as irreproducible as a photon's quantum state, turning every transaction into a one-time pad written in clay or light. The parallels run deeper than technique. Cuneiform symbols often nested multiple meanings within a single sign, a practice called polyvalence. The same wedge cluster could mean life in a temple hymn or interest rate on a lone tablet, its true meaning collapsing into clarity only when combined with other signs, like quantum bits existing in superposition until measured alongside their entangled partners. The Babylonians even had their own version of quantum erasure. Miswritten tablets were baked into permanence by fire, fixing errors into the archaeological record, just as quantum measurements commit particles to a single state, erasing all other possibilities. But the most striking overlap lies in how both systems handle fragility. A cuneiform tablet left in the rain blurs into illegibility, its wedges melting back into formless clay. Quantum information is just as vulnerable. Collapse the wave function, and the original superposition is lost forever. Yet both systems turn this fragility into strength. The Babylonians safeguarded treaties by burying copies beneath temple foundations, distributed across space and time. Quantum networks achieve similar resilience through entanglement swapping, where particles separated by miles retain their linked states, creating a distributed ledger no single point of failure can corrupt. What's haunting isn't just that the Babylonians anticipated encryption's core concepts, it's that they ritualized them. Scribes began tablets with invocations to gods, not just as piety but as metadata, marking the text's origin and integrity. Modern quantum protocols use authentication tags for the same purpose, digital seals that verify a message's untampered state. Both frameworks recognize that information is never just data, it's a covenant, a trust forged in wedges or qubits, demanding reverence and vigilance alike. So was cuneiform quantum computing, not literally, but in their painstaking strokes those ancient scribes grasped a truth we're still unraveling. That language isn't just a vessel for meaning. It's a latticework of relationships where every symbol pulses with potential, and the act of reading isn't passive, it's the knife edge that carves possibility into fact. Whether etched in clay or encoded in photons, the lesson remains: to share a secret isn't to bury it. It's to weave it into the fabric of the world so tightly that only the right hand can pull the thread. The Lion of Babylon wasn't just a symbol of power, it was a masterpiece of orchestrated chaos. Carved from basalt, this iconic statue depicts a muscular lion towering over a prostrate human, its body a study in contradictions, ferocity tempered by stillness, violence frozen into harmony. To the Babylonians, it represented divine order subduing mortal chaos. But there's another layer here, one that hums with the same eerie synchronicity as quantum coherence. That mysterious phenomenon where particles sync up across space, acting as a single, harmonious unit despite their separateness. Both the lion and quantum coherence whisper the same startling truth. From seeming discord, unity can emerge. Think of quantum coherence like this: when particles become coherent, they lose their individuality. Their waves align perfectly, like soldiers marching in lockstep or birds flocking without collision. This isn't just teamwork, it's transcendence, a state where separate parts begin to function as a whole. The Lion of Babylon embodies this same principle. The human beneath its paw isn't just crushed, they're integrated into a larger design, their struggle frozen into a moment of precarious balance. The statue doesn't depict domination so much as integration, chaos absorbed into order, just as random quantum states can phase lock into perfect alignment under the right conditions. The parallels sharpen when you examine how both systems handle disruption. Quantum coherence is fragile. A single stray photon can shatter the delicate phase relationships between particles, collapsing their synchronized dance into noise. The lion, too, is a monument to precarious stability. Archaeologists believe it once stood guard over Babylon's processional way, a silent sentinel amid the city's roaring crowds and clashing armies. Its power lay not in rigid control, but in its ability to contain chaos, much like a Bose-Einstein condensate, where ultra-cold atoms coalesce into a coherent superatom, their chaotic thermal motions quieted into unity. What's most striking isn't just the similarity of ideas, but the shared language of alignment. The lion's muscles ripple with tension, each strand of stone meticulously carved to suggest motion restrained. Quantum coherence, too, thrives on tension, the precise balancing of particle phases, where even a slight misalignment breaks the spell. The Babylonians might not have known about wave functions, but they understood the aesthetics of equilibrium. The statue's posture, one paw raised, weight perfectly distributed, mirrors the phase matching that lets lasers produce coherent light, where countless photons march in perfect lockstep. But here's where the metaphor deepens. Quantum coherence isn't just about particles getting along. It's the foundation of reality's most astonishing phenomena: superconductivity, where electrons flow without resistance; photosynthesis, where plants harness sunlight with near-perfect efficiency. The lion, similarly, wasn't just art. It was a tool, a talisman meant to channel divine order into the human realm. Both systems reveal a universe where coherence isn't passive. It's transformative, turning noise into music, discord into meaning. Perhaps that's why the lion endures as more than a relic. Its stone body, weathered but unbroken, stands as a testament to the same principle that fuels quantum technologies today. Chaos isn't the enemy of order. It's the raw material. Whether you're a Babylonian sculptor carving harmony from rock or a physicist coaxing atoms into coherence, the challenge is the same: to find the hidden rhythms that make fragments whole, and in that unity, discover a power greater than the sum of its parts. The Babylonian underworld wasn't a place of fire and brimstone. It was a realm of muted echoes where souls drifted like smoke through endless halls of dust. They called it Urkala, the land of no return, a grey expanse where the dead drank from brackish puddles and forgot their own names. Existence there was less a punishment than a slow fading, a gradual unraveling of self into the void. Now fast forward to quantum immortality, a modern thought experiment where consciousness refuses to die, branching eternally into alternate timelines where the observer always survives. At first glance, these visions couldn't seem more different, one a bleak oblivion, the other a glitch in reality's code. But peel back the surface and they share a chilling question: what if death isn't an ending but a threshold we don't fully understand? Consider Urkala's most haunting feature, its indifference. The Babylonian afterlife had no judgment, no rewards or punishments. Whether you were a king or a beggar, you ended up the same, a whisper of your former self, your identity leaching away like ink in water. Quantum immortality flips this script but lands in a similarly unsettling place. In this theory, every time you face death, whether in a car crash or a hospital bed, your consciousness jumps to a timeline where you survived while other versions of reality continue without you. There's no grand design, no moral reckoning, just the cold mechanics of probability, ensuring your awareness never experiences cessation. Both frameworks reject traditional notions of an afterlife governed by justice or mercy. Instead, they offer existence stripped of meaning, one through erosion, the other through endless replication. The ethical implications of these visions are staggering. For the Babylonians, Urkala's egalitarian gloom discouraged obsession with the hereafter. Why live virtuously if the end is the same for everyone? Their solution was radical. Meaning had to be seized now, in this life, through deeds that echoed in the memories of the living. Quantum immortality, by contrast, risks a different existential trap. If consciousness truly persists across timelines, does life lose its stakes? Why fear a cliff's edge if some version of you always walks away? Philosophers wrestle with this quantum solipsism, where the observer becomes the universe's sole anchor, rendering all other lives contingent, disposable. The Babylonian underworld erased individuality. Quantum immortality threatens to isolate it, trapping the self in a hall of mirrors where every reflection outlives the world around it. Yet there's a strange comfort in these parallels. Both systems, ancient and modern, grapple with the same unnerving truth. Death resists narrative. We want it to be a door, a transition with purpose, but what if it's just a flaw in perception? The Babylonians coped by ritualizing memory, pouring libations to feed their ancestors' fading shades. Quantum immortality's adherents turned to mathematics, finding solace in the equations that suggest experience might never hit a true endpoint. One culture built ziggurats to touch the heavens, the other builds quantum computers to simulate alternate realities. The methods change, but the yearning remains to crack the code of what waits beyond the veil, or whether beyond even exists. Perhaps that's the real thread connecting Urkala's dust and quantum branching. Both force us to confront the limits of human storytelling. We crave arcs, closure, moral cause and effect. But the universe, whether through the Babylonian stoic gloom or the physicist's multiverse, keeps whispering, existence might not play by those rules. The dead don't fade, they fracture. The end isn't a period, it's an ellipsis, trailing into versions of reality we'll never see. And in that uncertainty, both ancient myth and modern theory leave us with the same challenge: to live as if meaning isn't handed down by gods or quantum fields, but forged in the choices we make before the darkness or the branching takes us. Niels Bohr never set foot in Babylon, but his sketches of atomic models might as well have been lifted from a cuneiform tablet. The father of quantum mechanics famously doodled atoms as interlocking circles, their electrons tracing paths that mirrored the celestial orbits Babylonian priests charted millennia earlier. Heisenberg's uncertainty principled the idea that you can't precisely measure both a particle's position and momentum, echoes the fluid divination practices of Mesopotamian scribes, where omens shifted meaning based on the angle of observation. These weren't conscious homages to ancient wisdom. They were collisions of intuition, moments where the human mind, stripped of pretense, stumbled upon the same strange truths. The parallels emerge most vividly in Bohr's concept of complementarity, that light could be both wave and particle depending on how you interrogated it. The Babylonians would have nodded in recognition. Their pantheon thrived on duality, Ishtar as goddess of love and war, Shamash as both solar disk and divine judge. They didn't see contradiction in these pairings, they saw completion, a cosmic balance modern physics now encodes in wave-particle duality. Even Bohr's insistence that the opposite of a profound truth may well be another profound truth resonates with Babylonian dialectics, where creation myths often featured competing versions of events, each valid within its context. Heisenberg's uncertainty finds its precursor in the Babylonian terrifying light, a celestial omen recorded in the Venus Tablet of Amasajuka. When Venus flickered unpredictably, scribes didn't attribute it to measurement error. They saw a fundamental capriciousness in the cosmos, a divine refusal to be pinned down. Modern quantum experiments confirm this at the subatomic level. The very act of observing alters the observed. The Babylonians ritualized this principle through liver divination, where a sheep's organ became a quantum dice roll, its blemishes collapsing infinite possibilities into a single omen. What's most striking isn't the similarity of ideas, but the shared path to discovery. Both eras arrived at their insights by staring into voids, Babylonians tracking the empty spaces between stars, physicists probing the apparent emptiness of atoms. The ziggurat and the particle accelerator serve the same purpose, instruments to interrogate the unseen. Even their tools align. The Babylonians used base 60 math, a system elegant for its divisibility, to predict lunar eclipses. Quantum theorists rely on complex numbers with real and imaginary components, another divisible framework, to calculate probabilities. Different languages, same grammar of discovery. This cyclical return to ancient intuition raises a provocative question. Are we uncovering eternal truths, or is the human mind hardwired to interpret reality through certain patterns? The Babylonians lacked our technology, but not our capacity for wonder. When they mapped Venus's retrograde motion, they saw a god changing direction. We see orbital mechanics. Both explanations satisfy the same hunger to make the erratic comprehensible. Perhaps that's the deepest lesson. Science doesn't progress in a straight line. It spirals, revisiting old mysteries with new tools, each revolution uncovering layers the ancients sensed but couldn't prove. The irony is delicious. Quantum physics, the pinnacle of modern empiricism, has resurrected a world view the Babylonians would have recognized, one where certainty is fluid, observation alters reality, and the universe hums with interconnected potentials. We've traded clay tablets for supercomputers, but the song remains the same. And if history is any guide, future revolutions will send us circling back once more to find our cutting-edge theories were already whispered in the dust of forgotten archives. The universe keeps its secrets well, but it loves an inside joke. So where does this leave us after journeying from the ziggurats of Babylon to the quantum labs of today? The connections aren't just intriguing, they're profound. The Babylonians, without telescopes or particle colliders, crafted myths that dance eerily close to the truths modern science has only just begun to quantify. Tiamat's formless waters mirror the quantum vacuum's seething potential. Marduk's structuring of chaos echoes the Higgs field, giving mass to particles. The Tablet of Destinies, with its fluid fate, aligns with quantum probabilities collapsing under observation. These aren't vague similarities, they're uncanny reflections, as if ancient minds tapped into a universal lexicon of reality's deepest patterns. But here's the real revelation. This isn't about proving the Babylonians were secret physicists. It's about recognizing how human intuition, when unfiltered by modern assumptions, might sense truths that science later verifies. Myths weren't primitive science, they were a different kind of knowing, one that blended observation with metaphor to grasp realities too subtle for blunt instruments. The quantum world, with its paradoxes and probabilities, defies everyday logic. So does mythology. Both speak in symbols because some truths resist straightforward telling. Consider what this implies. If Babylonian scribes watching the stars and telling stories could brush against concepts like entanglement, superposition, and quantum fields, what else might ancient wisdom hold? The Vedas' descriptions of cyclical time resonate with multiverse theories. Indigenous creation stories often describe a universe born from vibration, strikingly close to string theory's vibrating filaments. Even alchemy's quest to transform matter finds a parallel in quantum tunneling, where particles defy classical barriers. The past might be richer with insight than we've dared to imagine. This isn't a call to abandon rigor for mysticism. It's an invitation to widen the lens. Science and myth aren't opponents. They're complementary explorers, one dissecting the universe with equations, the other mapping it with stories. Both at their best are attempts to converse with the unknown. So the next time you hear an ancient tale of gods shaping the world or heroes descending into underworlds, pause. Listen closely. Beneath the fantastical veneer, there might just be a whisper of quantum truth waiting millennia for us to catch up. Now it's your turn. What other ancient ideas strike you as eerily prescient? Could Taoist yin-yang duality hint at quantum complementarity? Does the Norse world tree, Yggdrasil, mirror the holographic universe theory? The comments are open. Let's unravel these threads together. Because if history teaches us anything, it's that the universe loves hiding its secrets in plain sight. And sometimes the oldest stories are the ones that see the furthest.